subgroup meta-analysis with a binary outcome based on the effect size, which is an odds ratio in R statistics, to generate a forest plot and funnel plot. So what is a subgroup meta-analysis? Subgroup meta-analysis is a statistical method that separate or divide the group into two or more subgroups and then perform meta-analysis on those subgroups to generate and calculate the overall or pooled estimate of effect size, which is in this case the odds ratio, and then compare the pooled effect size between these subgroups. So the subgroup meta-analysis can be performed when there is a binary outcome. So what is a binary outcome? Is a variable that have two levels in it. It is a categorical variable that have two categories in it. So it is dichotomous. It can be either yes or no, live or dead, smoke, doesn't smoke, and the odds ratio is a estimate of the effect size. So what is meta-analysis? Meta-analysis is a statistical method that combine and collect data extracted from several independent clinical or research studies that addresses a specific medical or research question. So the objective of the meta-analysis is to pool out all the data and generate an overall estimate of the effect size, in our case is the odds ratio, for a specific intervention or exposure compared to control or reference group. The meta-analysis will also generate and perform a heterogeneity test to assess and examine and evaluate the level of heterogeneity or variability or inconsistency among the results extracted from these or those several independent research or clinical studies, to generate a p-value and a I-squared value, which is represented in a percentage, and it is a measure for the level of heterogeneity among the results. 0% represents no heterogeneity appears or happen among the studies, and 100% value indicates maximum heterogeneity. Another important plot that is produced through meta-analysis is the forest plot. A forest plot is a diagram that displays the output of the meta-analysis or subgroup meta-analysis in a format that can be easily interpreted. There are three important sections in the plot. The first part is descriptive statistics for each individual studies, with odds ratio or effect size is given or is calculated, and the 95% confidence interval and a p-value and a weighted percentage. And the second section, which is a diagrammatic representation of the descriptive statistics, and a third part, which is a overall estimation of the effect size and a heterogeneity test with p-values and I-squared value. Also, from the subgroup meta-analysis, a funnel plot can be plotted. A funnel plot is a graph. It is a scatter plot. that displays on the x-axis the estimate of the effect size, in this case an odds ratio for each individual study, plotted against a y-axis, which is the standard error or can be the sample size. The shape of the plot is like a funnel, and the objective of the funnel plot drawing is to visually determine whether there is a bias of publication. To perform subgroup meta-analysis with a binary outcome and to use an effect size which is an odds ratio, launch the RStudio and then also import the file that contains the data for the studies. And the way to do that is to click on File and then scroll to Import Data Set, and the data file is saved in SPSS. So click on it, then browse and select the file. Select the file which contains the data and then click on Import. The data are loaded into R as shown here. From the table there are a few variables. The first variable or column is the study ID, and there are 12 different studies. The second column is the event, number of events occurring in each study. The third one is the total number of participant for each study, and the fourth one is the event for the control. So C stand for control, E stand for experimental. So the study, each study was designed to have two groups, experimental group or exposure group and a control group, and the event is recorded in each group, and the objective of the study is to assess the efficacy of a drug in treating certain condition, and if the condition has been recovered and the participant healed completely from the condition, then it is scored as an event occurring for the experimental or exposure, and if for the control, no treatment or exposure being given to a participant, and if a recovery from the condition happens, then it is recorded and scored as an event in the control. The NC stands for a number of total number of participants in the control group, and finally a section or a column or a variable that have gender in it, male or female. So 6 of the 12 studies, only males are recruited for the study, and for the other 6 only females are recruited. So here we have 6 studies with only males and 6 studies with only females. So here, to find out whether there is a difference in the efficacy of the treatment of the drug between males and females, then subgroup meta-analysis can be performed. And as the data here or the outcome is binary, either the event occur or it doesn't occur, so it is a dichotomous or binomial outcome, then the odds ratio will be calculated and the subgroup meta-analysis will be performed. And the way to perform subgroup meta-analysis in R statistics is to use the meta package. If the meta package is not installed, then install that into the R, and I've already installed the package. Library, open a bracket, type meta, and then hit enter. The library or the meta package is loaded into R. And to do a subgroup meta-analysis for a binary outcome based on the odds ratio, we'll use the command metapin for binary. And the first thing is to do is to generate an object, call it X, and then use the assignment operator and use the command metapin, open a bracket, and then insert the data name, which is in this case the file we called it as this one, and then insert that in that part here. So the data is the odd ratio meta-analysis. The next is to insert the event in a sequential event, exposure, n exposure, then event control, n control, and it has to be capital letter dot e, and then comma n dot e, comma, and then event dot c, comma, and n dot c, comma. So here the command is the metapin, and the data is the file which is given a name, OR meta-analysis. And the first column is the event for the experimental, the second one is the total number for the exposure or experimental, the third one is the event for the control, and the last one is the total number of the participant in the control. To choose a method for the analysis, type method, then insert a quotation mark, and then type MH method for Mantel-Haenszel method, and for the summary view type SM, and then equal sign, quotation mark, and then use the OR. Since we are using here the effect size estimates OR, we could use also risk ratio, but here our objective is to use the odds ratio. If we hit enter here, meta-analysis will be performed on the 12th study or studies. They all will be pooled, and an overall estimate of the effect size will be calculated, and the heterogeneity test will be performed for the 12th study. If we are interested in doing subgroup meta-analysis based on a factor or a variable, which is the gender, the meta-analysis will be performed, and the group of the study will be sectioned into two groups, male groups and females group, and the overall effect size for the male subgroup will be calculated, and for the females will be also calculated with 95% confidence interval and a p-value. And to do a subgroup meta-analysis, insert a comma, then use the command which is byvar, select the function which has a equal sign, and then type the factors or the variable to subgroup based on it. In this case is the gender. So this function will perform subgroup meta-analysis for the male group and the females group. To select also a random effect model, then insert comma after the gender option, and then type random equal T for true, and fixed equal to false. So here, as I want to use the random effect model, then T is true and fixed is false. If I want to swap, I want a fixed model, effect model, then fixed should be T and the random should be F for false. If I hit enter and then view the meta-analysis or subgroup meta-analysis, type X and hit enter. As shown here from the subgroup meta-analysis, the number of studies are 12 studies, the number of observation 1633, and the number of events 741. And the model selected, random effects model, and an odd ratio is calculated for the overall estimate effect size with a 95% confidence interval and a p-value. Also, the heterogeneity was quantified by two approaches, the tau squared and the I squared, and the 95% confidence interval is generated. For the I squared, the heterogeneity is equal to 0 and the 95% confidence interval is generated. For test of heterogeneity for the 12 studies, a Q statistic was calculated, which is based on chi-square and a degree of freedom of 11 and a p-value of greater than 0.05. So this result shows that there are no heterogeneity among the results from all the 12 studies, as the p-value is greater than 0.05 and the I squared is 0%. And for the subgroup analysis based on random effect model, the studies segregated into gender or based into gender, male and females, and the number of studies 6 for male and females. The odds ratio for male is given as 19.3 and 15.09 for female for females, and as shown here, the odds ratio, overall odds ratio for the 12 study is 16, for the male is 19.3 and females 15.1. A 95% confidence interval is generated for each subgroup with a tau squared and an I squared, and as shown here, there is no heterogeneity among studies, 6 studies from the male, and there is a 35.9% heterogeneity between the studies for females. So there is a heterogeneity for the females group, and there is homogeneity for the male group. And the last section here is the test for the subgroup differences based on a random effect model, which give a degree of freedom of 1 and a Q value and a P value greater than 0.05. To generate a forest plot, let's type here, let's clear this first, clear this, and then type forest and open up brackets and then X. And if I want to generate a forest plot based on already format, such as the ref format for forest plot, then type layout equal signs and then quotation mark revman and hit enter. And as shown here, if you click on zoom, forest plot is generated for the 12 studies. For the even subgroup meta-analysis, as shown here, this is the format for the revman forest plot. In this section is the study or subgroup based on the gender, which is male or females, 6 studies. However, the study ID is not inserted. We will do certain changes on the basic forest to add these. And also there is a section here for the experimental and the control, 2 groups for each study, events and total, and the weight percentage and the odds ratio calculated based on the random effect model with MH method, and a ratio, odds ratio with a 95% confidence interval, and a diagrammatic representation of the forest plot. So as shown here, there are three sections in the forest plot: the descriptive statistics, the diagrammatic representation, and the overall test, or the overall test and the effect size generated, and heterogeneity test. And as shown here, for each section a heterogeneity value is generated for the male and females section. So if I want to revert back to the basic format for the forest, and I insert and design the format as I would like, then we could use the basic command, which is forest, and then click on open a bracket, hit X, and as shown here, this is the format that is given when we use the forest command. We can see here the study label is missing, the events here are missing for the control and the experimental, and we could also do some editing for the section for the diagrammatic representation, and to add the study label. Exit of this view and then back into the command section here, forest, type forest X, then pooled. Let's first of all do the study label by using the study label command equal to, and then the study label is the study ID, so insert study ID, and if I hit study ID has to be capital letter, as the ID has to be capital letter, as R is case sensitive. If I hit enter and then click on zoom, the study label for each of the 12 for the male and the female are added here. To add the totals for the event, for the experimental and the control, exit of the plot, and then in the command section type again forest, open a bracket X, then keep copying the study label and insert that here, and then comma, and then type pooled event equal true, and hit enter and click on zoom. As shown here, the pooled event for experimental and control for the subgroups are added for all the missing data here. To do a few editing for this diagrammatic representation, to change the color of the square here, and also the line, vertical line, which is the overall odds ratio, then exit of the plot, and in the command section select the command here, forest, and paste, and then add a comma, and let's change the color of the square by typing color.square, and let's give it a color of red. And if I hit enter and click on zoom, as shown in the diagram here, the color of the squares are colored with red. To change the color of the diamond here, which represent the overall effect size, exit of this, copy the previous command, insert, and then add a comma, and then type color diamond and select the color diamond option, and then let's give the color of the diamond black, and hit enter, view it again, and as shown here, the diamond is colored black. And finally, to change the color of this line, let's say dotted or dashed line, to blue, close the plot, copy the command, and then paste that here and add to that comma, and then let's type column of the random, since we use the random approach, and then let's call it or give it a blue color, and hit enter, and then click on zoom. As shown here, it is a faint blue color is assigned for the vertical line. So this is some of the editing that can be done on the forest plot manually, rather than having already a pre-installed shape for forest plot based on RevMan. So from this subgroup meta-analysis, there are 3 sections as shown here: the descriptive statistics, the diagrammatic representation, and finally the overall. So from the section here, we see that the studies are sectioned into male and females based on the gender, and the experimental group in each study with the control, the events and the total are counted and inserted here, and the odds ratio for each individual study is calculated with a 95% confidence interval and a weight percentage, which calculates and add to it the value of the size of the sample into the overall effect into the meta-analysis. So higher percentage reflect higher participant number in each study. This is the descriptive statistics. For the diagram here, this is the plot which shows that the vertical blue line now is the overall effect size, which is an odds ratio, which is found to be around which is here around 16.24 for the overall meta-analysis without subgrouping. So this is the blue line, and for the small size squares with different sizes, that represent the odds ratio for each individual study. Larger squares represent larger study with larger number of participants. The horizontal line is the 95% confidence interval. The diamond-shaped structure or symbol here reflects the odds ratio for the male subgroup, and the one here is the females subgroup, and for the male value is given here, and for the females the odds ratio for it is given here. And as we can see that there are variation, the males higher, females lower, and the overall for the 12 study without segregation is 16.24. This with segregation based on gender, there is a variability in the odds ratio. The third section here is the heterogeneity among the study when they are segregated into male and females, and for the overall effect. As shown here, for the male, the heterogeneity, the I-squared is equal to 0, and the p-value is greater than 0.05. So there is no heterogeneity among the 6 studies for the male. For the females, the I-squared is 36%, and the p-value is greater than 0.05. So there is a heterogeneity among the results from the 6 studies, which only includes females participant in it. And the last one is the heterogeneity for the overall meta-analysis rather than sub-meta-analysis. And as shown here, the I-squared is 0% and the p-value is greater than 0.05. And A test of subgroup differences is also generated here. So from this forest plot, it is possible to look at the overall effect size based on just meta-analysis, or we can segregate the studies into two sections, males and females, and then calculate, perform meta-analysis for each subgroup, and then compare the outcome from those two groups. This is for a subgroup meta-analysis generating forest plot. To generate a funnel plot is plotted to determine whether there is a publication bias, and to draw the funnel plot is just type funnel, open a bracket X, and then hit enter. And if you click on zoom and drag the graph to this section here, as shown here, a funnel plot or a funnel shaped diagram is generated, and on the x-axis is the odds ratio for each individual study. The odds ratio is the estimate of effect size, and on the y-axis is the standard error or the sample size. So this is a scatter plot with small circles here represent the odds ratio for each individual study. The line on the middle here is the overall effect size. So this funnel plot is for not the subgroup meta-analysis, it's just only for the whole 12 studies. And the distribution of the studies in reference to the overall odds ratio, which is around 16.3 here, has to be equally distributed above and below the line. So here we have 1, 2, 3, 4, 5, 6, 7 on the above section of the value for the overall or pooled odds ratio, and have 5 below. So there is a degree of bias in publication from this funnel plot, and another step need to be done, such as Eager's regression test to confirm that observation. So this is the way to perform subgroup meta-analysis for a binary outcome based on the effect size estimate, which is the odds ratio in R statistics, to generate a forest plot and funnel plot.